Let's talk about the delta, or also known as the hedge ratio. Delta is an important parameter in the pricing and hedging of options. Here we have the definition. The delta of a stock option is the ratio of change in the price of the option to the change in price of the underlying stock. So as we can see from the formula, we have FU minus FD. So this is the change in the price of the option. FU being the option value in the high state and FD in the low state, so when it goes down. And then SU1 and SD1, they denote the change in price of the underlying stock. Okay. And to go into more detail, the value that we get for delta is going to be the number of units of the stock we should hold for each option shorted in order to create a riskless portfolio. Okay, this is the aim, to get a riskless portfolio. So let's use this in this next example. The example reads, suppose that there are only two possible future states of the world. In one state, a company's share price will rise by 50%, and in the second state, it will drop by 10%. The current share price is £100. The exercise price of a European call option written on the share is £110, and then the risk-free interest rate is 5%. Calculate the value of the delta, hedge ratio, of the call option. Okay? So all we need for this exercise is to get the option values and the stock prices values, okay, in state U and state D. So let's start with the current share price. The current share price is £100, and then in the binomial tree, the price is either going to go up or down. Now it says in one state a company's share price will rise by 50%. Okay, so in that case, U, which is the magnitude of the rise, the magnitude of the up jump, is going to be 1 plus that percentage, which is 50%. Decimal places, that's 0.5. So U is 1.5. In order to get the share price in the high state, we need to do the initial share price times U, which is going to give us £150. In order to calculate the magnitude of a down jump, so when it goes down, we do 1 minus the percentage, which in this case is drop by 10%, so 10%. So 1 minus 0.1, which gives us 0.9. Then we do £100 times 0.9, which gives us £90. Okay. We always write the option values below the share prices. So we have FU on top, FD, and then F, which is the current option value, which we don't need for this exercise. Okay, next thing is to calculate these option values. Now, because the exercise says this is a call option, this means that the investor is going to make money when the share price is higher than the strike price, or the exercise price, which in this case is £110. Remember, an option gives you the right, not the obligation, to exercise the option, okay? Therefore, the investor is only going to exercise the option when he's making money. Okay, so FU in this case is going to be the share price minus the exercise price. We can see that the share price is higher than the exercise price, so the investor would be making money. Therefore, he does exercise it, and more precisely, he gets 150 minus 110, which gives us £40. So £40 is the value of the call option at FU. What about at FD? In this case, the share price has gone down to £90, okay? And the exercise price is £110, which means that the investor is losing money, okay? Now, because an option gives you the right, not the obligation, to exercise it, because the investor is losing money, he wouldn't exercise the option, okay? Which means that the option would be worthless. Therefore, in this case, we can write FD is equal to 0. Okay, very good. So now we have the option values, FU and FD, and we also have the stock values, SU, which is the stock price once it's gone up, and then SD, okay, stock price once it's gone down. So now we can calculate the delta. So delta, which is denoted by this Greek letter, is equal to FU, which we know is 40 pounds, minus FD, which is 0, over SU, which we know is 150, minus SD, which is 90, and this gives us 40 over 60, which if we simplify gives us 2/3. Okay, or in decimal places we could also write 0.67. Okay, so this is the value of the delta in this exercise.